Welcome to aminacademy.com. In chemistry, let us discuss about ionic compounds. In last videos, we talked about salts that are ionic compounds made up of cation and anions. Many of the rocks and minerals in Earth's crust are made up of cation and anions held together by ionic compounds. The ratio of cation to anion is always such that an ionic compound has no overall charge. For example, in sodium chloride, for every sodium plus cation, there is a chlorine negative anion to balance the charge. One more example, in magnesium oxide, for every Mg2 plus cation, there is an O2 negative anions. Ionic compounds also share certain other chemical and physical properties also. Ionic compound is a chemical compound composed of ions held together by electrostatic forces termed ionic bonding. The compound is neutral overall but consists of positively charged ions called cations and negatively charged ions called anions. These can be simple ions such that the sodium Na plus and chlorine Cl minus in sodium chloride. Here, ionic bonds do not consist of molecules. When we go through a water molecule, if you look closely enough into the water, you would find individual water molecules each made of 2 hydrogen atoms and 1 oxygen atom. The pot would be filled with many billion and billion of these individual H2O molecules. But recall that smallest crystal of table salt that you could see contains many billions of sodium and chloride ions held together by ionic bond. However, if you could look closely enough into the salt, all you would see there are many sodium plus and chlorine negative ions all bonded together to form a crystal. There are no NaCl molecules. All are ionic compounds. It is not NaCl molecules. Here, normally elements in group 1 and 2 in periodic table reacting with elements in group 16 and 17 will almost always form ionic compounds and do not molecular compounds. Next, we'll talk about ionic bonds are strong. Here, both repulsive and attractive forces exist within the salt crystal because of cation and anions. The repulsive forces include those between like charged ions. If like charged ions, they repulse each other within the crystal. Each Na, for example, each Na plus ion repulses that other Na plus ions because both have positive charges. The same is true for chlorine negative ions also because they are having both negative charges. Another repulsive forces exist between the electrons of ions that are close together, even if the ions have opposite charges. The attractive forces include those between the positively charged nuclei of one ion and the electrons of other nearby ions. In addition, attractive forces exist between oppositely charged ions. These forces involve more than a single sodium plus ion and a single chlorine negative ion. Within the crystal, the sodium cation is surrounded by 6 chloride anions. At the same time, each chloride anion is surrounded by 6 sodium cations, vice versa. As a result, the attractive forces between oppositely charged ions is significantly greater in a crystal than it would be if the sodium cations and chloride anions existed only in pairs. That means ionic bonds are very strong. Next, distinctive properties of ionic compounds. All ionic compounds share certain properties because of the strong attraction force between their ions. Compare the boiling point of a chloride. Boiling point of the chloride is 1413 degrees Celsius. Compare with water molecule compound, that is boiling point of water is 100 degrees Celsius, because chloride is ionic compound. Similarly, most other ionic compounds have high melting and boiling points also. To melt, ions cannot be in fixed location because each ion in this compound forms strong bonds to nearby ions. That is why the ionic bond compounds have very high melting point, because each ion is surrounded by oppositely charged other ions. Considerably energy is required to free them. That means the ionic bond should be broken to melt the ionic compound, so we need more energy, that is more heat, which is high melting point. Still more energy is needed to move ions out of the liquid state and cause boiling. As a result of their high boiling points, ionic compounds are rarely gaseous at room temperature. Mostly ionic compounds are solids, while many molecular compounds are ice. For example, compounds are, for example, ice, for example, will eventually melt and then vaporize easily. Here, because molecular compounds is easily melt because the attractive force is lesser than by molecular compounds. Dissolved salts conduct electricity. Here, when salts dissolved in water or other liquid is easily conduct electricity because its ions are conductive nature of electricity. To conduct an electricity, a substance must satisfy two conditions. First, the substance must contain charged particles, that is ions. Second, those particles must be free to move. Because ionic compounds are composed of charged particles, you might expect that they could be good conductors. While particles in a solid have some vibrational motion, they remain in fixed location as in ionic compounds. However, when ion can move about, salts are excellent electrical conductors. Next, salts are hard and brittle. Like most other ionic compounds, table salt is fairly hard and brittle. Hard means that the crystal is able to resist a large force applied to it. Brittle means that when the applied force becomes too strong to resist, that is a brittle nature, the crystal develops a widespread fracture rather than a small dent. The ions in a crystal are arranged in a repeating pattern forming layers. Each layer is positioned so that the cation is next to an anion and the next layers. Like that, these salts are arranged. Next, we will talk about salt crystals. Crystal lattice, the regular pattern in which the crystal is arranged, called a salt crystals. In itself, the smallest portion of crystal lattice that shows that three-dimensional pattern of the entire lattice. Here, we will talk about the salt crystals. The ions in a salt crystal form repeating pattern with each ion held in place because there are more attractive forces than repulsive forces. The way the ions are arranged is the same in a number of different salts. The repeating units are arranged in a salt to form a crystal lattice. These arrangements of repeating units with a salt are the reason for the crystal shape that can be seen in a most salt. In further video, we will do in further videos. We have done. Please subscribe our YouTube channel. We have done.